Okay, so I'm going to have our panelists just introduce themselves and kind of talk about their take on the movie. And I will come and collect if anybody has question cards, or if you have a question and you didn't write it down, you can ask that as well. So we're just going to start right off.
Okay. You want to go, Mark?
Yeah, hi. My name is Mark Hammergren. I'm an astronomer and a planetary scientist at the Adler Planetarium. By planetary scientist, I mean my research specialty is on asteroids, so the so-called small bodies of the solar system. Now, I've done a little bit of research on Mars, and I've seen the movie about 4 or 5 times, so I do have a little bit of a background in that. Now, I also in college studied some filmmaking. For a while there, I was going to be part scientist, part filmmaker. And I've acted as a science consultant for some movies and TV shows. So I have that kind of background working on that as well. And Shane?
Yeah, so I'm Shane Larson. I'm a professor at Northwestern University and associate director of our Center for Interdisciplinary Astrophysics. I'm a gravitational astronomer, so I spend most of my time thinking about gravity and orbits and dynamic interactions of bodies. So the sort of stuff you see in here that's probably close related to what I do is the transfer orbits and the stuff that he was computing to try and get the ship back to Mars. I do a lot of public science communication and a lot of interface with folks talking about astronomy. I generally teach intro astronomy and intro physics all the time, so I'm very used to spending a lot of time trying to take really complicated things like this and explain how it works to the best of our abilities. So, yeah.
No, let's talk about the movie. And also, we want to open up to any questions you might have. I have a couple comments. I think the first is this is 4th or 5th time I've seen the movie, and I have to say that I actually enjoyed this movie probably the most this viewing. And part of the reason for that is the very first time I saw the movie, I was supposed to talk about the scientific accuracy in The Martian in a TV interview following that showing. So, before the movie came out and when it was in the theaters, there was a lot of really big hype, I have to say, about how accurate the science was. NASA was really crowing about how they advised the movie and how accurate it was. And so that really primed me to look for the inaccuracies. There are some inaccuracies in the movie. And so I was kind of in that nitpicky mode when I was seeing that movie, the first couple times even. Now, I think the very biggest issue I had with the movie was really the whole setup, the whole, what set this whole plot in play, the storm, the dust storm on Mars. And I have to say, number one, the dust storms on Mars are really huge. That is, they can cover the entire planet. In fact, Mars is right now going through a global dust storm. But the storms are nowhere near as violent as depicted in the movie here. And the reason for that is, even if the winds get very high, in the movie they're supposed to be about 100 miles an hour, well, winds on Mars have been detected up to about 60 miles an hour. It's not implausible that they could reach 100 miles an hour. But the atmospheric pressure on Mars is very low. It's about 1% of the Earth's atmospheric pressure. So that means that a 100-mile-an-hour wind on Mars would feel like a 10-mile-an-hour breeze on Earth. And there's no way it would be breaking antennas and throwing people around. It would blow dust around, that's for sure, but it wouldn't have that violent effect that we see in the movie. And I have to say, and the author of the book, Andy Weir, admits that he threw that storm in, made it so violent, for dramatic effect, to set the plot in action. So he acknowledges that that's kind of not really a very accurate depiction. And yeah, when it comes to movies, I'm all for watching a movie for its, dramatic sense rather than the scientific details. But when you hype a movie as being so incredibly accurate, and then the very first thing that happens is really off, that set a kind of a bad tone for me.
Yeah, so to play off of that, I was at a Star Trek convention once, which happens to some of us. And I asked Bill Shatner what he thought the purpose of telling science fiction stories was. And he said, you know, we always focus on science and the kind of technology and how accurate it is. But he said in the end, he always thought stories were telling stories about us. And this interview that Mark was saying where Andy talks about the dust storm, Andy said that he accepted that beginning part because he wanted this to be a story about people versus nature and Mark's survival on this planet that was very inhospitable, and I think that's what they did. It's funny as a scientist watching movies because you have a tremendous amount of technical training and you have a tremendous ability to see things and instantly in your head think, oh, well, that's inaccurate in the following ways, and I can figure out how to make it correctly. But there are definitely movies that we as scientists connect to. For a whole generation of scientists, it's the movie 2001 because of the accuracy that they depict, you know, spaceships in space. There's a whole group of us who love Contact very much because of the way it portrays our philosophy about science. And there's a whole group of us who love this one very much, mostly because of the technical wherewithal they went to try and get it in place. I think the thing about this movie I find most compelling are the characters, because I know all of those people and they're all colleagues of mine. There's people just like them all over. That business with Rich Parnell, you know, in his office sleeping and spitting coffee in the coffee can, that's what it's like some days, you know. It's just kind of the way it goes. And so I think I really thrive on this movie on the people, because the way you see them approach problems, what Watney says at the end, you break them down, you work through them one at a time. That's the way we do science. And we do science that way every day, and especially in dramatic situations like this, that's the way NASA does science. That's why they bring crews home. And so I think that really resonates with me in this movie. But yeah.
Yeah, I absolutely agree. When I see a movie, I really look to enjoy myself and, you know, just look at the.
We all
the
like
movie.
Armageddon as much as the next people.
Yeah. Well, maybe not as much as the next people, but. Speaking of the characters and maybe some of the social aspect, there were two problems I noticed that really bothered me. And number one is when they are on Mars, before the storm hits, they're sounding kind of bored. There's some banter going on, and Watney is collecting the soil samples, and he's sounding kind of, you know, like this is just kind of boring. They're on Mars! Excuse me. No astronaut is going to be non-excited at all. If you listen to the audio, the actual audio of the Apollo astronauts on the moon, holy cow, they were having a blast. They were singing. They were so excited almost every moment. So I would have liked to see a little bit more of that absolute wonder, like, holy moly, I'm on Mars, and look at this thing here, look at this. So I would have liked to see that. And the second thing that bothered me too was how the NASA director would not image the site on Mars, at the site of the accident at the HAB and so on, that they wanted to kind of keep that under wraps. And, you know, I can tell you that if an accident like that ever happened for NASA, they would throw every single resource they had to try to figure out what happened and what went wrong. So the very first thing they would do is use any satellites orbiting Mars to get a clear picture of what happened.
Yeah.
So there
because
would
of what
be no
they said,
cover-up.
right? They have to plan for the next mission. They don't want it to happen
Absolutely.
again, right? Yeah,
Yep. And
exactly.
accident investigation is a huge thing for NASA.
So anyway, so I think we've chatted enough. How about we take questions from folks? Yeah. So do y'all have any questions you want to ask? So should we just call on folks? Yes, in white there.
Yes. How did you both first become interested in your particular field of study, and how old were you?
I was a kid. Yeah, I'm old enough that I grew up during the Apollo missions. And so, you know, I was watching people walk on the moon. I was watching those Saturn V's on TV lifting up. Nothing sounds like a Saturn V going up, you know. And so that really got me interested in, I was thinking, I'm going to work for NASA when I grow up. And I was given a telescope right around the same time. So I couldn't really find things in the sky besides the moon too well. But that was really enough to start my interest. As for my interest in asteroids, why I like those kinds of space rocks, I think it's a visit to the Field Museum when I was a kid. and I saw this exhibit on meteorites, and specifically there's one that fell down near St. Louis in Bennold, Illinois. A meteorite punched through a guy's garage and lodged in his car, and they had pieces of the garage and the car in that exhibit. And as a kid, I had no idea that kind of thing could happen. And I thought, wow, a meteorite hit that guy's car. How cool is that? And it stuck with me.
Yeah, so I grew up in the Rocky Mountain West, in a little tiny town centered around the timber industry. So I grew up being able to see the night sky, right, which is something that you can't do so easily here in Chicago. But I, like Mark, at a very young age, I learned to stargaze. I grew up. I was in 6th grade when Cosmos came out, so I'm really a Sagan kid. And so, when I talk about astronomy and I see stuff like this, I hear Carl Sagan's voice in my head talking to me about all of this stuff. And that really, I think, is what pushed me over the edge at the right age. So this gentleman right here in the front. So. Yeah, so that's a good question. So Elon Musk wants to do it soon, right? So a related question to that is people often ask me, what's the most unrealistic thing about this movie? And my answer is usually the budget NASA has to do what you see happen here, because I think we have the technical capability to go to Mars, and the stuff that you see there comes very close to stuff that NASA has proposed. I think ultimately the thing that's going to be the hardest is figuring out how to pay for it. And it's not anything more than deciding that we have the desire and the will to go. When we went to the moon with Apollo, which Mark saw happen, there was a concerted effort on the part of the United States to pour money into it. And if you look at that, we spent a lot of money to go to the moon, but in reality, a lot of the modern world came out of that. Our computer technology and fancy fabrics and Velcro and all those things you hear about came from the Apollo program. And so one of the difficulties that we have as a society is recognizing the value investing in something as big and as imaginative as going to Mars. But I think that's ultimately what's going to be the hard decision to make.
No, it's just a matter of choices, though, because there are government spending programs, some defense spending that over a long period of time, the same kind of time it would take to develop a Mars mission, these programs are going to be spending close to $1 trillion. So that kind of money could fund a Mars mission. It's just a matter of choosing what we want to spend it on.
Yes, sir. Yes.
Don't you think with the change in both AI and just the kind of robotic technology we have, that it makes way more sense to send equipment that are remotely operated to do 90% of the science until we get farther along?
So this is a common viewpoint, and it's one that we as scientists struggle with and talk about all the time. Sending humans costs a lot more than sending robots, but sending humans gives you different kinds of capability. The kind of most succinct summary of that I think that I've ever seen was a statement by Gus Grissom, who was Apollo 1 commander. He died on the Apollo 1 fire. But he was very vocal in his notion that you really want to send humans, because the true value of exploration is someone who is a human and has all the same experiences as you, seeing it up close and personal and having that visceral connection to the universe and being able to describe it to you in a way that a stream of scientific data or just a picture from a robot never will. So there's that very human aspect of it, and it's something that I think we are all kind of familiar with in our own explorations and discoveries of the world. We understand what that kind of emotional connection is. And so that's not probably the primary reason you would send a human instead of a robot. There are things that humans can do that robots can do. You can pivot, you can change, you can alter what you're exploring. The Apollo 15 astronauts were trained to look for specific rocks that a robot would have never found because they weren't trained with the eye of a field geologist. So there's reasons to send humans, but this argument that you've just made is the one that we have to dance around to understand. And it's what Mark was just saying about investment. Yeah.
And it's not an either-or thing. We are going to continue to send robotic missions to Mars in the short term, because honestly, they cost a lot less than human missions to Mars, and so we can afford sending them up without too much pain from the government every few years, every opposition of Mars, basically. We've got InSight on the way to Mars right now. So and also a nice viewing opportunity of Mars coming up here this summer. It's making a relatively close pass by the Earth, so it'll be bright in the night sky. Good telescope target.
Yeah, it'll look like a bright red star, and the small telescope or a pair of binoculars, you'll be able to tell how red it really is. So,
There's a question in the back. Oh, yeah. So it's already becoming brighter, but around end of July is when it'll be best visible. And it'll be visible, nicely visible a month or two before and after that.
yeah, most of the night, right? Yeah. Yes.
Question, yeah. Actually, that very thing, capturing a small asteroid or grabbing a small piece of an asteroid and bringing it back to Earth orbit, was in the works. That was being planned for a while. It was called the Asteroid Redirect or Asteroid Retrieval Mission, and that was really driven by a presidential directive, I guess. President Obama said, "We're not going to send people to Mars. We're going to send astronauts to an asteroid." But when they looked at the details of that, it would be cost prohibitive to launch a mission to visit an asteroid out in space. And it would take months, so we'd never done anything like that. So somebody had the brilliant idea of grabbing a small asteroid and dragging it back to Earth orbit. Now, the plans got scaled back so much that it got kind of ridiculous. The asteroid they're talking about would be between, say, 1 and 2 meters across. So a chunk of rock maybe 6 feet across. And sending astronauts up to visit that and retrieve samples, like exploring something, when it's already like bagged and attached to a spacecraft, would have really been a ridiculous mission. And that was canceled, thankfully. I don't know of anybody in the planetary science community who supported that. But that kind of thing is possible. And eventually someday astronauts might visit an asteroid. Typically, though, it'll be robotic spacecraft that are doing that. It's not as high priority a target as something like Mars.
So to go back to an earlier question, the question about AI and things, technology is advancing rapidly. And one of the reasons that you can imagine wanting to land on an asteroid is because of the resources it contains. And so there is lots of very forward-thinking people who try and imagine, could we land on an asteroid, an automated factory that would harvest material from the asteroids and return it back to Earth because we want more precious metals and semiconductor parts, or more to the point of what we care about watching a movie like this, can it build the spacecraft that we need them to do to continue to explore and move farther out? If we build habitat on Mars or the moon or somewhere, we're not going to ship all of that stuff from Earth there. We're going to mine those materials and develop them locally because it's far more cost effective, and that will require technology and AI and things like that to really do it in a sophisticated way that'll make it possible. So, but that's still future stuff, right? That's not, we're going to do it next week.
Question up front.
Okay, so I'm going to give you some physics homework to do on the way home. Okay, so when you're driving home, right? You're going to be cruising down Main Street here in Lake Forest, and just take say your water bottle, and as you're driving along, throw your water bottle up in the air. And what'll happen is the water bottle is going to come straight back down and land in your lap, even though the car has moved 100 feet from the place where you dropped the bottle to the place where the bottle landed in your lap again. And so what's happening is the bottle's moving with the car. It's moving exactly the same way as the car, so it's almost like the car isn't moving. And this is what you see. This is one of the things they did kind of good there, right? There's no air in the capsule, so he's not getting sucked out because all the air is rushing out. It's empty space, just like outer space. But he's moving in the same direction as the ship. And so the ship moves and Watney moves with it. So as long as he stays holding on to the ship and in the middle of the ship, not with his hand shooting him far away, he's not going to get pushed away from it. He's moving in the same direction at the same speed at the same time, so he stays with it. In the same way that your water bottle stays with you in the car when you throw it up in the air on the drive home. Don't do it on the driver's side, do it on the passenger side. So, okay. Does that kind of make sense? Okay.
Question in the middle there on the end. Ooh, what's the difference between SpaceX and NASA? SpaceX is a private company that builds rockets, builds launch vehicles, builds spacecraft too. So it's a private company, uses private money to develop it, but then sells these missions to the government. So ultimately, it's the U.S. government, mostly, and some other foreign governments, I guess, when they send satellites up, that are paying for these rockets. So the money ultimately comes from U.S. government, comes from private companies too, that send up satellites. So that's probably not what you're getting at. That's a technical, that's a financial detail. One of the big differences with this between SpaceX and NASA, though, is SpaceX is, again, it's a private company, and so they have just a philosophy that they can take bigger risks than NASA. NASA is a big organization, tens of thousands of people, and they do everything very slowly, very deliberately, very formally.
Because they're spending our money.
Because they're spending our money. Yeah, they have to justify every single thing to all of the politicians. SpaceX doesn't have to do that. And so when they built their Falcon 9 Heavy rocket, they spent somewhere more than $500 million of their own money, private funding, to develop that rocket. Of course, they're then selling the missions to people, but yeah, they can afford to take bigger risks.
What are some new propulsion ideas or concepts that are being thought of or in development, and how would that potentially change a trip from Earth to Mars?
So the biggest problem with conventional space travel is carrying fuel with you to drive your rocket. Rocket fuel is heavy, and rocket propulsion is very inefficient. So that's why it takes a rocket as tall as a building to send a spacecraft the size of your Volkswagen into orbit. Once you're in space, there are other things you can try and do. Conventionally, you'll still use propulsion like rocket propulsion, but there are new ideas. Probably the most famous one is something called ion propulsion that NASA used on the Dawn spacecraft that just went to minor bodies in the solar system. It is an electric form of propulsion. It is more efficient than chemical rockets, but it's very slow. So it just kind of slowly accumulates and drives your speed up over long periods of time. And so when you imagine using technology like that, say to send people, it's very hard to imagine the cost benefit of using that kind of technology over rocket fuel, because you end up paying for it because you have to sustain the astronauts for longer, for instance. Yeah.
And it uses a lot of electricity.
Yeah, you can do it with solar panels,
yeah,
right?
So right now you can use solar panels as long as you're relatively close to the sun, not going out to the outer planets. Then because the light drops off, and your solar panels would have to be that much bigger. Now, some people have proposed using nuclear power sources, so you'd have nuclear electric propulsion, and that is a potential really revolutionary propulsion method. But it involves sending nuclear material into space, and a lot of people have problems with that.
But all that nuclear material came from space to start with, right? So, okay. Other questions? Yes, sir.
We talked about some of the areas where maybe the film might
Yeah. So, I mean, I think the thing that's most striking to me is the visuals of Mars. Now, they're not accurate. I mean, we have accurate maps of Mars. We know lots about what Mars looks like. But I think one of the things that struck me very strongly watching the film is the sheer vista of Mars on a scale of this screen is something that I've never really experienced before. And all of that kind of, immersion in the environment, I think, is something that really kind of speaks to me when I watch the film. The topography and everything, it's clear they've used Earth landforms, and the gravity's not right for the astronauts and everything. But this kind of sheer, desolate, as far as you can see to the horizon, barrenness is something that really stood out to me when I watched that film, even now. So, yeah.
And it's some of the small details, well, some not so small details. The dust devils that we saw in a few scenes, those actually absolutely occur on Mars, and they can be huge, stretching up for kilometers up into the sky. You can see them from space, from the orbiter images. Now, another detail, too, I saw in some of the scenes. You could see some of the moons of Mars in the background up in the sky, and they're irregularly shaped, so that was handled really quite nicely. I also really loved the technology. I mean, that spacecraft, the Hermes spacecraft, beautiful. And just the details, the flight benches in the capsule, in the MAV. It really looked very technically accurate in that respect. Yeah, I appreciated that.
So Mark said you could see the moon. So in the scene where he first turns on Pathfinder and he points the antenna to Earth, right? If you look in that scene, you'll see Earth, just this blue dot in the sky over the mountains there. And there's a very famous picture that one of the rovers took. I mean, that's just spot on the way it looks. It's a pale blue dot in the sky, right? I mean, that's what home's going to look like from Mars. So that was kind of a cool detail that they made sure they put in. So.
Question in the back, yeah.
If companies like SpaceX can perform missions on their own volition, and say like NASA with all the sort of political stuff they go through, is it smarter to fund them instead of NASA, or is it more dangerous because they have less kind of politics and checks and balances?
So risk is a funny thing, right? So there are a group of people who are children of the space age who are looking at where we are today and asking, why aren't we where we thought we were going to be when I was 10? Why don't we have space hotels and regular voyages to space that I can take, and why aren't people living on the moon and Mars? And so there's a very strong trend among a certain group of people, Pete Diamandis, Elon Musk, all of these folks, to really bring that privatized version of space to the forefront. And in their heads, if you listen to them talk about this, what they will remind you of is that this is the way commercial aviation developed in the beginning of the 20th century. There was a time when there weren't airplanes, and in the course of a few decades, we got to the point where commercial air travel was something that was possible for ordinary people. But if you look at the history, it was not easy, and people died. And that's because private people can take risks, and they're willing to take risks because they have a goal they want to achieve. And as Mark said earlier, NASA and the government agencies are highly risk averse because of the extreme microscope that they're under, because they're spending money that you and I allocated to this. And I think people see space travel, and they see space shuttles flying and astronauts going to the moon and all those things, and they forget how inherently dangerous this really is. And so when bad things happen, it kind of really brings to the front this question of, is it worth risking human life? And there are people who believe it absolutely is, because that's the way technology and our capability in these kinds of arenas move forward. But then there's others of us who are not so sure.
Yeah, question up front.
Yeah, I've got a gravity guy and an asteroid guy.
How come every question starts that way?
Do we have, if you guys aware of any sort of credible thing to kind of respond to asteroid issues? I know we've been mapping them, trying to keep track, and really, it's actually, to me, it seems somewhat of a significant issue, and I don't know if there's been progress.
This is your part.
Yeah. So we actually had a program running for about 2.5 years based at the Adler, using an observatory in postdocs that I hired, we observed more than 3,000 near-Earth asteroids during that period of time, specifically to nail down their orbits so that we could see where they're going, make sure they're not hitting the Earth. So that was funded by NASA. And I think one of the greatest success stories relating to asteroids that just hasn't gotten enough press is that these surveys that NASA has funded have found more than 95% of all potentially hazardous asteroids larger than about a kilometer or so. That's roughly the threshold where you get national scale or global scale impacts. None of that 95%, so about 900 plus asteroids, none of them is on a collision course with Earth. That means that for at least our lifetimes, those asteroids do not pose a threat to Earth. And that's a remarkable risk. Yes. I think we should. We're not going to have to worry about Armageddon in our lifetimes, right?
Especially since Bruce is getting old. I mean, he's not going to be there to save us anymore.
Now, smaller ones can still pose a threat. Smaller asteroids can still pose a threat if they happen to come down at the wrong place. There was an example of that a little over 5 years ago. A 55-foot wide chunk of rock entered the skies above Chelyabinsk, Russia. And whereas none of the solid chunks of rock that remained from that thing, the largest piece that remained was about 3 feet across, none of those caused any damage on the ground when they hit. In fact, they're more curiosities than anything. Meteorites, hey. But the sonic boom from that huge chunk of rock coming in at about 40,000 miles an hour, that sonic boom broke windows in more than 6,000 buildings, and more than 1,600 people were sent to the hospital with injuries, mostly from broken glass. And that was just a small 55-foot wide chunk of rock. There are hundreds of thousands of asteroids that size, and they, on average, hit the Earth every 50 years or so. But that doesn't mean it'll be 50 years. It means that one could be coming tomorrow. And we know of maybe 1% of all those asteroids that have been found. So the vast majority are undiscovered yet.
But they will hit the Earth, right? I mean, it's going to happen.
At some point, it will absolutely happen, yeah.
Yes, sir.
On that issue, is there a particular mitigation technique that you think?
I like Bruce Willis, but, that's just me.
I think the very most important thing is to have as much lead time as we possibly can. So that I think the effort should be really spent on funding better surveys, not only ground-based telescopes. Let's have a space-based telescope that can look closer to the sun. That asteroid that came in over Chelyabinsk, Russia, it never would have been seen by any asteroid surveys when it was on its final approach, because it came in the daytime. Its path was coming from fairly close to the sun in the sky. And ground-based telescopes have to observe at night. You can't point towards the sun. Space-based telescopes, though, can. No atmosphere to blur out the sun. You can search that kind of near-sun space for hazardous objects.
What Mark says is really important, right? What we actually need to know is the orbits of all of these things. Because there are we have all kinds of ideas for how to mitigate, how to deal with something like this. But none of them's tested, and none of them has ever had to been thought about carefully, right? But the day that there is one where we know it's going to hit us, right, the longer we have to think about it, the more likely it is we're going to figure out the right way to deal with it. And there are all kinds of ideas, ranging from tying solar sails to them and letting the sun do its job for a century, to putting rockets on it, to putting another asteroid near it so the gravitational tug of that asteroid slowly alters its orbit before it gets to Earth, right? There's all kinds of things you can imagine doing, but none of them do we today have the technology in the box ready to go, because we don't have to, right? And so what Mark said is absolutely right. You have to have time, because time and crisis and knowing exactly what the problem is what allows your scientists and engineers to figure out the thing that's going to work. And we haven't had to face it yet, but someday we will.
Now, there's an interesting political aspect that has not really been looked at too much regarding asteroid deflection. Nudging an asteroid off course is the best option, I think, really, especially if you have a lot of lead time. But imagine this situation. Let's say an asteroid is going to be, it's found on a collision course and it's seen, oh my gosh, it's going to hit Illinois. We need to nudge it off course. But anytime you nudge it off course, that's going to push its impact location. It's going to push its potential landing spot in some direction. So, let's nudge it off course. Well, that means that you'll push it off of Illinois, and it might go over Indiana instead. And then the governor would say, no, you can't do that. Send it off the other direction. And then the governor of Iowa would say, no. Now imagine that on an international scale, because anytime you move it in one direction, you're going to put somebody else at risk. And coming up with some solution to those politics, we're going to have to face it if we ever see an asteroid coming at us.
Other questions?
Question in the back, yeah.
Do you know anything about the UN-sanctioned Asteroid Day that's supposedly coming up in about a week?
Yeah. So Asteroid Day is it's set to be celebrated annually on the day of the Tunguska blast, a large asteroid impact that happened over Russia in 1908. And that one was such a large impact that it blasted down a forest in that uninhabited area, mostly uninhabited, more than 50 miles on a side, hundreds of square miles of blasted down forest. And it was roughly at the same latitude as London. So if the Earth had rotated about 6 hours more, that thing would have come down over London. And now impacts that size happen every 100 or 200 years, roughly on average. So there's a possibility of an impact like that occurring at some point in the future. So that's when they celebrate Asteroid Day. Really, the biggest organization pushing Asteroid Day has been this one called the B612 Foundation. They want to build a space-based observatory to detect asteroids. Now, unfortunately, they've been around for maybe 10 years or so trying to gain funding. A mission like that will take hundreds of millions of dollars, and they've managed to collect something like a couple million. There's not a chance in the world they're going to be successful pushing their mission. So instead, they're pushing Asteroid Day to get people interested.
Anything else? Okay.
Great. Thank you so much.
Thank you, everyone. We hope you had a good evening. We'll do it again sometime.